This video is going to give you an introduction to thermochemistry. Thermochemistry just has to do with the study of physical and chemical reactions that involve some type of change in heat. Heat is a form of energy, so we could say heat's a form of energy, but we need to know what that means. Energy is the capacity to do work, and there are all different kinds of energy or types of energy. So we have thermal energy, which we're going to be looking at really closely in this video, which is the energy that's associated with the motion of the particles. We talked about chemical energy so far a lot this year. It's just the energy stored within chemical bonds. Nuclear energy we're going to talk about more at the end of the year, but energy stored within the collection of neutrons and protons and reactions involving different subatomic particles. Electrical energy is energy associated with electrons. We'll talk a lot about electrical energy when we get into redox and electrochemistry, talking about how batteries work. And potential energy is pretty much stored energy. We've talked about how you could talk about a roller coaster, and at the top of the roller coaster you have potential energy. So it's available by virtue of its position. But we really want to focus on heat. That's what this chapter is all about. Heat's going to be represented with the letter Q. So let's say you were doing a problem and they asked you to solve for density. We know that density equals mass over volume. You would set it up as D equals. Well, here, if they're asking you to solve a problem for heat, you're just going to set up as Q equals. We have a couple of equations that relate to Q, and we're going to get more into them in the next video. So heat is basically a transfer of energy from one object to another. So if I put two objects that are at different temperatures next to each other, heat's going to flow between them. Heat always goes from the warmer object to the colder object. So when we're looking at a problem involving heat transfer, just look for the higher temperature, and heat will go from the object that's at the higher temperature to the object that's at the colder temperature. So is temperature the same thing as heat? No, absolutely not. Heat is the transfer of energy because two objects are at different temperatures. Temperature is just a way that we can measure the heat change. We can measure the temperature of the objects before and after the change. So temperature is the average kinetic energy, or a measure of the heat energy, whereas heat is the energy itself. Well, what are the units for heat, or the unit for energy? Because heat's a form of energy. The unit is going to be a joule. We haven't really talked about this yet. So remember, all the units are located on table D on the front of your reference table. So if you get confused, you're not really sure, remember to check back there. Whenever it says heat or energy, the unit will be joule. So let's say we do a certain calculation that's with heat. We want to make sure we put the value of our answer and then a capital J. Another way of expressing what the heat is, or another unit for heat, would be the calorie. For pre-IB, we definitely need to know what a calorie is. The calorie does not appear on the regents anymore, though. So when you say you burn calories, all that you're saying is you're saying how much heat your body has generated. The heat is measured in calories. But the calorie quantity that we typically use when we're looking at food labels and such is actually a kilocalorie, not the calorie that we'll be calculating. So if we calculate calories in a problem, if we were to convert it to kilocalories, that would be the equivalent big C that appears on the back of your food label. So when we talk about heat transfer, we want to know, well, is a system absorbing or releasing heat? We've talked about absorbing heat is called endothermic, or endothermic process. In this case, if your heat is going to be absorbed, it's going to have a positive Q value. An exothermic process is one that releases heat. We talked about when you're released from school, you walk out the exit. So exothermic is releasing heat, just like an exit begins with X, EX, has that same prefix. When you lose heat or give up heat, you're going to have a negative Q value. So here's a picture of a flask inside a box, and what it's just showing you is sometimes we get confused whether it's exo or endo depending on whether you're talking about the system or the surrounding. So if we're looking at the solution itself and heat is being absorbed, in this case on the left, it's endothermic or endothermic process. If heat is leaving the system or leaving the flask, it's an exothermic process. Okay, so here's two examples for you. Oftentimes, like if you're going skiing or something, or let's say you're going to the St. Patrick's Day parade, you may want to bring hand warmers. We've all seen these Hottie's hand warmers or something similar to it. Hottie's hand warmers, if you hold them in your hand, are going to feel hot. We just said that heat flows from hot to high to low, or hot temperature to a lower temperature, hot to cold. So if I have the hand warmer in my hand and it's hot, heat will flow from the hand warmer to my hand because the hand warmer is hotter than my hand. So that would be an exothermic process. The hand warmer is releasing heat. On the other hand, touche. I could put a cold pack on my hand. Cold pack is going to feel cold. So what's happening here is that heat is leaving my hand and being absorbed by the cold pack because my hand has a higher temperature than the cold pack. So that would be an example of an endothermic process because the cold pack, which is our system, is absorbing heat from the surroundings. So a hot pack is an example of an exothermic reaction, and a cold pack would be an example of an endothermic reaction.